Okay, so this is really what you guys have been thinking about when I told you we're going to have a trig unit. This sine, cosine, and tangent, or these abbreviations that you see that look like sin, cos, and tan. I think this is what a lot of people get freaked out about with the trigonometry unit because these are completely new words. The ratios are, not even mentioned until you get to a geometry class, but they are a good foundation for your upper level math classes. So we are going to keep it basic here in geometry, but those of you, when you get to your upper level math classes, you're going to just expand on these right triangles and all these ratios, and you might even get to take the upper level trig class, which I believe is a college credit. So anywho, this is the basic trig functions, or these are the basic trig functions. And for this lesson, we're just going to create the ratios. Okay, so next week's assignment and lesson will focus on using these ratios to actually solve for a missing part of a triangle. Okay, so we're going to elaborate more on these ratios next week. This week, though, we're just going to make those ratios so you can kind of make sense of how to use them in a real trig problem, and then how to set them up using this new vocabulary. So what is trigonometry? Well, trigonometry is basically just the study of triangle measurement. Okay, a little bit off the paper there, but it's just studying triangles, specifically right triangles here, and the measurements that can be found within that triangle. So when you're making these ratios, we're going to be focusing on the right triangle, which has a hypotenuse and two legs. Now, in your right triangle, that hypotenuse is always going to be the longest side, and it's going to be across from your right angle. Okay, so this ratio statement here says each acute angle of a right triangle will have the following trigonometric ratios. Now, it says each acute angle because in a right triangle, those other two angles are going to have to be acute. They're not going to be able to be obtuse because since your hypotenuse is always across from the right angle, your hypotenuse is the largest of the three sides. So you can't have an obtuse angle somewhere else because that would mean that the larger side would be across from that obtuse angle, okay? But your largest angle in a right triangle is that 90-degree angle. And so the hypotenuse is always going to be across from that. So these other two angles are going to be acute. All right, now here's how we come up with our sine, cosine, and tangent ratios. All right, and then we're going to have this little, which you might have heard of already, this little acronym, I guess, that is going to be huge for this whole trig unit. So here's how the ratios go. For our sine ratio, which is abbreviated sin, S-I-N, it's the ratio of the leg opposite of the angle in question to the hypotenuse. Okay, so you're always going to know what the hypotenuse is. It's the side across from the right angle. Now, when it says the leg opposite, okay, the leg is a side. Opposite means it's going to be across from, like I said, the angle in question. So if we see the sine of angle A or the sine of angle B, we'll look at this angle in your triangle. Here's angle A, capital letter A. So we're going to look here first. Now, sine is going to be the leg opposite of that to the hypotenuse. Remember, a ratio compares two numbers. So I'm going to write this as a fraction. Okay, well, what leg is opposite of angle A? Well, if I look at angle A right here, directly across from it is the side with the lowercase a. Just like I drew this arrow from the right angle to the hypotenuse, it's across from it. It's opposite of it. But if I look at angle A, the lowercase a is across from it. So it's the opposite compared to the hypotenuse. Well, the hypotenuse is labeled with a C. So this ratio of the sine of angle A is sides A to C. Okay, now let's look at angle B. All right, the sine of angle B. Well, here's angle B. Okay, what's the opposite leg and the hypotenuse? Well, in this case, if I look opposite of angle B, it's the side or the leg with the lowercase b. The hypotenuse is still, and always will be, C. Okay, so this is just writing the ratios. We're just writing the trig ratios. We're not solving for anything with these. We're just setting them up. Cosine is also a ratio, but it's a little different. It's the ratio of the leg adjacent to the angle and then to the hypotenuse. So remember, we read ratios as, one number compared to the other. A to C, B to C. All right, this ratio is going to be the leg adjacent to the hypotenuse. Okay, so cosine, which is abbreviated with COS, we're going to find the cosine ratio of A and the cosine ratio of B. So again, let's look at angle A. What is the leg adjacent to that angle? And then what's the hypotenuse? Well, adjacent means next to. Okay, so for sine, we were looking across from. What leg was across from that angle? Adjacent, you are looking next to it. Now, a lot of people say, well, how do you know which side next to it? There's two sides that are next to it, but this isn't called a leg. This side that also makes up angle A, that's your hypotenuse. Okay, so this is a leg, this is a hypotenuse. So we're going to write the ratio of the adjacent leg to the hypotenuse. Well, the leg adjacent to angle A is side B, or leg B. So the cosine of A is B to C. Okay, well, now let's look at angle B. All right, capital letter B means the angle in this picture. So what's adjacent to it? Well, adjacent would be whatever's next to it. Well, the hypotenuse is next to it, so that's got its own letter. The leg that's adjacent to it is lowercase a. So the cosine of B would be written as the ratio A to C, side A to side C. And the last one we're going to make is tangent, which is abbreviated as tan. Now, tangent is the ratio of the leg opposite the angle to the leg adjacent to the angle. Okay, so let's find the ratio of tangent angle A and tangent angle B. So we're going to write opposite to adjacent. Okay, well, here's angle A again. What's opposite angle A? It's side A. What leg is adjacent to angle A? Well, the leg adjacent to angle A is B. So we're doing opposite to adjacent. Okay, so let's do the same thing. Tangent of angle B. Well, what's opposite of angle B? What's adjacent to angle B? Well, opposite of angle B is going to be lowercase b. Adjacent is going to be the lowercase a. Again, we can't use this as the adjacent side because that's not an adjacent leg. It's an adjacent hypotenuse. This says leg to leg. Okay, opposite to adjacent leg. So tangent of B is going to be B to A. Okay, here's how you remember, because this is a lot to remember. It's a very specific order, and each of the three ratios are different. Here's how we remember sine, cosine, and tangent. SOH, CAH, and TOA, SOHCAHTOA. Okay, if there's anything you remember from our trigonometry unit, I want you to remember SOHCAHTOA. Okay, these are obviously the first letters of the words in these ratios. S is sine. So the sine ratio is the opposite leg to the hypotenuse. So sine equals opposite over hypotenuse. So that's what we did up here. Ka of SOHCAHTOA is for cosine. C is for cosine. A is for adjacent. H is for hypotenuse. So the cosine is your adjacent leg over your hypotenuse. And again, in reference to whatever angle that you have. And then TOA is for our tangent. So T is for tangent, and then we've got our opposite leg and our adjacent leg. SOHCAHTOA. So this is how we're going to remember how to set up these ratios. So if you have to set up a sine ratio, just think of SO. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA is opposite over adjacent. Now, if you're going to be using the hypotenuse at all in your ratio, it's going to have to say hypotenuse. If it says opposite or adjacent, it's going to be referring to one of the two legs. All right, hypotenuse is always referred to as hypotenuse. That way you don't get confused of which of the three sides are we talking about. Okay, so this is going to be our example problems, of course, for our notes, and this is what you're going to be doing in your homework. So I didn't want to move on with our trig ratios and calculate anything yet, just because we have one less day to our work week. Okay. In the directions, it says, give each trig ratio as a fraction in simplest form. So whenever you guys have fractions, try to remember to simplify them, okay? So sine, cosine, and tangent of angle A, and then sine, cosine, and tangent of angle C. So let's start with angle A, right here, okay? Well, our sine ratio is going to be the opposite over the hypotenuse. Well, what's opposite of angle A? It's the side with the 5. What's the hypotenuse? Well, the hypotenuse is across from the right angle. So our hypotenuse is 13. So the sine of angle A is the ratio 5 to 13. Okay, and we can't simplify that any further, so we're just going to leave that there. Okay, cosine of angle A. The cosine is the adjacent leg over the hypotenuse. So adjacent to angle A is this leg right here with the 12. And again, we're writing it over our hypotenuse, which is still 13. So this ratio is 12 to 13. Okay, now for tangent, that's our TOA. Okay, tangent is opposite over adjacent. So if we're referencing angle A again, the opposite side would be 5, and the adjacent would be 12. Don't say that the adjacent is 13 because the adjacent is referring to a leg. So we're referring to the 12, which means we're going to put 5 over the 12. Okay, so there's our ratios for angle A. Let's do our ratios for angle C. All right, here's angle C. So here's where we're referencing now. The sine is going to be the opposite leg over the hypotenuse. Well, what's opposite of angle C? Now we're looking over here. So that's 12 over 13. Hypotenuse is still 13 since we're working with the same picture. Cosine is the adjacent leg over the hypotenuse. So what's adjacent to angle C? Well, the leg that's adjacent to it is the 5. The hypotenuse, again, 13. So 5 to 13. And tangent is the opposite leg over the adjacent leg. So the opposite leg from angle C is the 12, and the adjacent is the 5. So it's a ratio of 12 to 5. Okay, so let's move on to number 2. I'm going to leave out example 3 because it requires you to do the same things as number 2, which is use the Pythagorean theorem. So I'm just going to do these 2 examples because your homework problem is going to be doing one of these. All right, so I'm just going to do example 1 and example 2. Now, if you look in example 2, we are only given 2 of our sides. We're given the legs, but we don't know what the hypotenuse is. Well, how do we find the missing side of a right triangle? That's where our Pythagorean theorem comes into play. Okay, we are finding C. C is always the hypotenuse, which is always across from the right angle. So our legs, which the A and B for the legs are interchangeable, the legs are 9 and 12. So to set this up, we would do 9 squared plus 12 squared equals C squared. If you carry that math out, you're doing 81 plus 144 equals C squared. After you add these up, you get 225 equals C squared. Now to solve for your missing variable in the Pythagorean theorem, you have to do the opposite in this last step. And the opposite or the inverse of squaring something is taking the square root. All right, so we're going to square root both sides, and our hypotenuse ends up being 15. Okay, so I'm going to erase this question mark. And the length is a 15. So that should be the longest of the 3 lengths because the hypotenuse is the longest side. So now that we know all 3 sides, let's set up our ratios for example number 2. Sine, cosine, and tangent for angle W. Sine, cosine, and tangent for angle X. So here's angle W, which is what we're referencing first. The sine is our opposite leg over the hypotenuse. So what's opposite of angle W? Across from it is the 12, and the hypotenuse is 15. Cosine is the adjacent leg over the hypotenuse. So what leg is adjacent to angle W? It's the 9. And the hypotenuse is 15. The tangent is the opposite leg over the adjacent leg. So the leg that's opposite of angle W is 12. The adjacent is the 9. Okay, now one thing I haven't done, which I'm going to do all at once now, is simplify these ratios. So if we simplify 12 over 15, we get 4 over 5. 9 over 15 is 3 over 5. And 12 over 9 is 4 over 3. Okay, so let's do angle X right here. Sine is the opposite over the hypotenuse. So opposite is 9, hypotenuse is 15. Cosine, adjacent leg over hypotenuse. Adjacent leg is 12, hypotenuse 15. Tangent, opposite leg over adjacent leg. Opposite is 9, adjacent is 12. Okay, so let's simplify these. Oops, I have to write my equal sign. 3 over 5, 4 over 5, 3 over 4. Okay, so again, all we're doing here in this is setting up these trig ratios, and next week we will use these trig ratios to solve for a missing side.